Hello, my name is Sean Cooper, and I'm a senior color scientist here at ARRI. In this talk, I'll be going into details about the Reveal color science system in the Alexa 35, and more specifically, the ARRI Color Engine 4, the ARRI Wide Gamut 4, and the new log-to-log ARRI look file 4. So to discuss the ARRI Color Engine 4, I wanted to take a step back and describe a bit what it means to have a color engine in the first place. The color engine's role is, in simple terms, to convert the signal from the ARRI camera into something that's equal to what a human visual system would see. The International Commission of Illumination refers to this as a standard observer. So this is precisely the role of the ARRI Color Engine 4. Our ARRI cameras do not see the world natively the way humans do, and so a calibration step is required. And this is what we refer to as a color engine. That is, that the core engine, or the color engine, converts a native RGB signal into a calibrated or colorimetric state. So in our previous Alexa cameras, we were restricted to a global optimization of this color engine. That is, a single transform that applies to all colors. Because of this, we optimized our cameras for natural colors and skin tones, resulting in the industry-leading skin tone and natural response of our cameras. However, saturated colors like LED lights, neon, and emergency vehicle lights were reproduced less faithfully than we desired due to this restriction. For the Alexa 35, we wanted to do even better. The ARRI Color Engine 4 allows us to do a local optimization where we can simultaneously calibrate for natural skin tones and natural objects, as well as saturated lights like LEDs, neons, and emergency vehicle lights. This, along with the unique advanced color match feature, results in our most color-accurate camera to date. But these improvements are not restricted to the Alexa 35. Older ARRI RAW footage will be able to adopt the new Reveal color science system, as well as this new advanced ARRI Color Engine 4. Thus allowing it to seamlessly integrate with Alexa 35 footage. Now I'd like to discuss the ARRI Wide Gamut 4, the new color encoding for the Alexa 35 and the Reveal color science system. The improvements offered to us by the ARRI Color Engine 4 allowed us to rethink our camera gamut. As stated before, the global optimization of our previous Alexa cameras resulted in a less faithful representation of saturated colors, and this can actually be seen in the ARRI Wide Gamut 3. As you can see, there are large overshoots beyond the spectral locus. This is due to its attempt to encode signals beyond the standard observer. With ARRI Wide Gamut 4, this was no longer necessary. We designed ARRI Wide Gamut 4 to tightly bound the spectral locus, as we're able to produce a calibration which is more faithful to the standard observer. Let's see an example of this. So here's quite a punishing scene. It's a high contrast bar scene, with sky panels at maximum saturation and pointing directly at the camera. On the right, you can see a scatter plot of the chromaticities in the image. As you can see, despite the difficult nature of the scene, the camera is able to faithfully reproduce the colors as the DOP would have seen them on set. In addition to being tightly bound to the spectral locus, thanks to our improved color accuracy, the choice of the primaries, that is, the definition of what red, green, and blue values represent, was chosen after extensive conversation with colorists, as AWG4 with ARRI Wide Gamut 4 primaries are used as a working space for grading. And the new color space and new primaries allows for exceptional behavior in your current grading tool of choice. And now I'd like to discuss the ARRI look file 4 and its improvements in the Reveal color science system. But to discuss this further, let's take a step back and look at the ALF2 file. The ALF2 workflow represented what we call a log-to-video transform. That is, it took log-C signal as input and directly converted it to output for a specific display device, such as Rec 709. The ALF2 file would then represent a combination of both the creative intent of a production as well as a technical transform to a specific display device. While this worked up to a point, it is a current trend in productions that they're required to provide multiple deliverables. That means for a single theatrical release, you may need to provide a Rec 709 SDR transform, a DCI P3 transform for cinema or theatrical release, as well as a Rec 2100 transform for HDR streaming at home. And while a DOP on set with the ALF2 workflow would only be able to see a single transform at a time, they would either be able to watch SDR or HDR, and not have the confidence on set knowing that the other represented their creative vision. The ALF4 workflow solves this issue. The Reveal color sign system and the ALF4 were built from the ground up with multi-deliverable and simultaneous SDR and HDR mastering in mind. The ALF4 does this by separating the ALF2, which is conceptually two parts, into its principal components. So the ALF4 now represents the creative intent of a given production, and the Reveal color science LUTs now handle the transform from AWG4 into a particular display device. And this allows consistency of your creative intent across multiple display devices, including HDR. The ALF4 transform now contains what we call a log-to-log transform. That is, the input and output color space are AWG4. This allows a DOP or colorist to create a look which utilizes all of the information within AWG4, including the extended dynamic range and carrying it all the way through to delivery or to final display in SDR or HDR. And with the new ALF4, you can simultaneously view these through the two SDI feeds, or as well on the HDR option available on the MVF2 viewfinder. This new workflow in the ALF4 and the Reveal color science system allows a user to easily create a look in the grading tool of their choice, upload it to the camera, and be assured that their creative vision is carried through to any display, on-set or in post-production. To view more details about how to create a look, I invite you to view the video of my colleague Utsi, where he walks you through his process of creating a new look for the ALF4 and the Reveal color science system. I hope this provides some insight into the Reveal color science system for the ALF4. I would encourage you to view the videos of my colleagues, which go into depth about AWG4 and the extended dynamic range of the ALF4, as well as the process of creating a new look for the ALF4 system. Thanks for watching.